Good evening, everyone. So, welcome to my YouTube channel, Supremum. So, today we are going to see third lecture on sequence. Okay. In last lecture, we have seen what are called bounded below sequence, and we have seen what is bounded above sequence, and finally, we have seen what are the bounded sequences. It turns out that a bounded sequence a sequence is bounded if and only if it is bounded above and bounded below. Okay. So now we are moving to define what is unbounded sequence. Okay, unbounded sequence. Okay. Unbounded sequence. A sequence AN is said to be unbounded if the sequence AN is not bounded. Okay. Okay. So if a sequence is not bounded, that sequence is called unbounded sequence. Note that a sequence is unbounded a sequence AN is unbounded AN is unbounded if and only if either AN is not bounded below or AN is not bounded above. Because we know that if a sequence is bounded, either it is both bounded above as well as bounded below. So if a sequence is not bounded, it means it is unbounded sequence. Either it will be not bounded below or it will be not bounded above. That is why it is unbounded. Okay. So example, in yesterday's class, we have seen that this sequence is not bounded above. Because if a sequence is bounded, it will be bounded above as well as bounded above. If a sequence is not bounded above or bounded below, then it cannot be bounded sequence. So it means it is an unbounded sequence. Because a sequence is bounded if and only if it is bounded below as well as bounded above. Now this sequence is not bounded above. So what does it mean? It means this is unbounded sequence. Okay. Now example 2. This sequence minus n is not bounded below. So this sequence is not bounded below. So what does it mean? It means this sequence is unbounded. Okay. we move to define a new concept, least upper bound, or you can say it's supremum. Okay. Least upper bound, second name is supremum. Supremum or least upper bound, supremum and least upper bound both are same meaning. Okay. So let A and be a bounded above sequence. Okay. If capital K is an upper bound for an and no number, okay, no number less than K is an is no number less than K is an upper bound for an, then K is called K is called sorry, yeah. No number less than K is an upper bound for an, then K is called, capital K is called the least upper bound or supremum. Its second name is supremum for this sequence an. Okay. For example, I am taking the example. You take this example. This sequence -1 to the power n. Okay. So we know 1 is an upper bound for this sequence. Okay. Now, if we take if we take alpha less than 1, then alpha cannot be upper bound for this sequence because if alpha is an upper bound for -1 to the power n sequence, then what will the meaning? It will mean alpha is upper bound, so it means -1 to the power n for all n belongs to n. Now taking odd natural, even natural number. So taking even natural numbers and we get, if we put even natural number here, we will get 1. Okay, but this is a contradiction. This is a contradiction to the fact that alpha is less than 1. Okay, so this implies 1 is a least, 1 is the least upper bound. 1 is the least upper bound or supremum okay for this sequence. For the sequence -1 to the power n. Okay. Now another example I am taking this example. You take this sequence 1 upon n. Okay. So 1 upon n is always less than 1. So this implies 1 is an upper bound for this sequence. If we take a number alpha less than 1, then alpha cannot be an upper bound for this sequence because if alpha is an upper bound okay is an upper bound for this sequence, then what will happen? Then what will happen? 1 upon n will be less than alpha for all n belongs to n. So taking n is equal to 1, we get what we get. 1 will be less than alpha, which is a contradiction. Which is a contradiction. To the fact that alpha is less than 1. So this implies 1 is the least upper bound or supremum for the sequence Okay, for this sequence, 1 upon n. One upon n. Okay, example 3 I'm taking. You see this example. This sequence is bounded above. So you see that minus, this is always less than minus for all n belongs to n. Okay, so this implies minus 1 is an upper bound for this sequence. If we take alpha less than minus 1, then alpha is not upper bound for, because if alpha is an upper bound for minus this sequence, then what will happen? Minus n will be less than alpha for all n belongs to n. So we taking n is equal to 1 because this statement is true for all n. We get, what will we get? Minus 1 will be less than alpha, which is a contradiction. Which is a contradiction to the fact that minus 1 alpha is less than minus 1. Okay. Therefore, minus 1 is the least upper bound or supremum for the sequence. Okay. Okay. So I'm writing not result 1, I'm calling it least upper bound or supremum supremum for a sequence is always unique. Okay. Let's see its proof. Let this sequence an be a bounded above sequence. Okay. Assume that K and K dash are least upper bounds or supremums for the sequence A. Okay. Supremums for the sequence. Okay. For the sequence AN. Okay. Since K is supremum, K is, so we need to show that we need to show that we need to show that K is equal to K dash. Okay. Okay. Since K is least upper bound or supremum for the sequence AN, we get K will be less than K dash. Okay. Because it is a least upper bound, and least upper bound is a upper bound, and K dash is also upper bound. So K is least upper bound, so it will be less than any other upper bound. K dash is another upper bound, na? So that is why this is happening. Similarly, K dash is least upper bound or supremum for the sequence AN. We get K dash is less than any upper bound. So we have this. From 1 and 2, we have from 1 and 2, we get K is equal to K dash. So this implies least upper bound or supremum is always uniform. Okay. So now this is done. Result 2. Let an be a bounded above sequence. Okay. Then A is least upper bound or supremum for an if given epsilon greater than 0, there exists a and not such that k minus epsilon is less than a and not. Okay. There exists and not belongs to natural number and not belongs to natural number such that this happens. Okay. Let's see its proof. Proof. First, assume that k is the least upper bound or supremum for the sequence an. Now let m greater than 0. Then k minus epsilon is strictly less than k. By definition of the least upper bound or supremum, we have that k minus epsilon cannot be is not because if a number k is least upper bound, then no smaller number than k can be upper bound. So is not upper bound for this system. So what is the meaning of this? This implies that if this is not an upper bound, then an less than k minus epsilon for all n belongs to n. This statement is not true. Is not true because otherwise it will be become no. This statement is not true. If this statement is not true, it means there will be some n. So this will imply there will be some natural number belongs to n such that because this statement is true, there will means what? This statement is not true. It means there will be some natural number that this condition is being violated such that a minus epsilon is less than a and o. Okay, so this is proof. One direction is proof. So conversely, assume that k 21 epsilon greater than 0, there exists and not belongs to n such that k minus epsilon is less than a and naught. Okay, we now let alpha is less than k. Okay, so we write one condition here. And you write this condition here. N is a bounded sequence, bounded above sequence be bounded above with upper bound k. K is upper bound. Then k is least upper bound for supremum if and only if this happens. Now, convergently state we are assuming converge statement. Let alpha less than k. Then k minus alpha is greater than 0. Okay. 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 So put epsilon is equal to k minus alpha. Okay. By assumption, by assumption, there exists and not belongs to n such that k minus epsilon a and not will happen. Now, what is this? Put the value of epsilon here. This is k minus alpha. Okay. So this implies what is this? After solving, you would get alpha. So this implies you have a term of sequence which is greater than alpha. It means this condition a n less than alpha for all n belongs to n is not true. Is not is not true. So it means what? If this is not true, it means alpha is not an upper bound for this sequence. Okay. Since as k is an upper bound for an and no number alpha less than k is an upper bound. We get what is the meaning of this? If k is upper bound and no number less than k is an upper bound for the sequence an. For an. So what we get that what is the meaning of this? The meaning of this implies k is the least upper bound or supremum for least upper bound or supremum for the sequence an. Okay. So this part is also proved. Convert part is also proved. Okay. So today's lecture for this, if you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you for next lecture.